discussed with Ohm's law, right? We verified Ohm's law, right? What is Ohm's law here? That tells us simply voltage is proportional to current, right? That means increase in the voltage, automatically we will observe the current also increases through a conductor, right? So here it is applicable for only metals. So this is limitation. Here metals are called as ohmic conductors. The remaining which do not obey the Ohm's law, they are called as non-ohmic conductors, right? Do not obey, they are called as non-ohmic conductors. Here simply non-metals gases, right? They are called as here non-ohmic conductors. Example, non-metals and gases. They called as here simply non-ohmic conductors. Then by the graph also you are able to decide the type of material here. If you observe the curve voltage versus current is rectilinear, then it tells about simply ohmic conductors, right? If you see the curve is here non-linear curve, it may be ascending or descending, right? So that you will tell simply non-ohmic conductors. So materials are two types, ohmic and non-ohmic conductors. So what you are taken on the axis X here, the component you are taking on the X is here voltage V in a volts. Then I on a axis X, sorry, Y, right? So in your intermediate, one more you are learning, that is here I on a axis X and V on axis Y. So voltage versus current you are drawing, and current versus voltage also you are drawing. So anything, both are correct, right? So but in our 10th class, it is given voltage on axis X and current on axis Y. This is only you can remember. Okay. Then here simply voltage and current relation we notice. That is what relation here. Voltage increases and also it increases the current in the conductor. So this is observed by Ohms. So that's why this law is called as Ohm's law, right? So according to this law, materials are classified into two categories. They are here ohmic conductors and non-ohmic conductors, right? So here the definition of the ohmic and non-ohmic conductors are given here. Just focus here. Right? At a constant temperature. At the constant temperature, you will find that here the potential difference between the ends of a conductor is directly proportional to the electric current passing through it at a constant temperature, right? So this is Ohm's law. That means here simply you are able to understand there are affecting factors on the voltage and current, right? So current depends on what material nature. What is material nature? That is only here introduced. Simply, if you remove this proportionality concept between voltage and current, what we will write here, voltage by current is equal to constant. The ratio between the voltage and current will give you a constant. That means simply V1 by I1 or V2 by I2, V3 by I3, right? For any values, right, they are increasing the same proportionality, right? So here simply that we understood here itself giving you constant. The constant is given here as R. So what is R here? R is the nature of the material, that is said to be resistance. That is said to be resistance. So what is here resistance? What is here resistance? That constant takes the units. V equal to IR is given. Then from this R equal to, we are able to write V by I. So here units of potential difference is volt, and current units are amperes. Then volt for ampere was named as ohms. So 1 ohm equal to 1 volt for 1 ampere. 1 ohm equal to 1 volt for 1 ampere. So these are the units of resistance. Ohms. We can use ohms as a resistance of the, units of the resistance. Units of the resistance. So here symbolically we can represent that ohm as here Greek symbol omega. Greek symbol omega. But read as ohm. Read as ohm. Symbol omega. Here reading as ohm. So this is about resistance. So resistance is what simply you need to define. You need to define. Here resistance is depending on the nature of the material. Nature of the material. Right? So that resistance maybe it is more for some materials. It may be very, very less for some other materials. Right? So here, depending on the type of material, that means simply the material made up of what? Right? Made up of what? So matter here. Nature of the substance, matter here. That atoms, which we use it to make it this wire, right? So that material nature will affect the amount of current passing through it. It depends on the voltage, but that amount of current will vary for another material. For example, what I said here, Ohm's law is V is proportional to I. For all metals, I said, right? All metals, I said. Suppose if you are maintaining the constant voltage, that is suppose 240 volts, right? And you collected the materials, right? Made up of copper, made up of aluminum, made up of iron, or made up of silver if it is possible, right? So you are collected these materials, wires, right? These materials, wires, right? What you are maintaining here, it's a temperature constant, length fixed, area fixed, right? Length, temperature and area fixed. Then you are finding current passing through it. I equal to what? Right? Potential difference also fixed. It is V, 240 volts. Then if you measure the current allowed through copper ones, aluminum ones, iron ones, and through the silver ones. Suppose here through the copper you got something 0.5 amperes current by fixed length, fixed temperature, and fixed area. By fixing all these three together, right? And also voltage. Then if you change the material, suppose if you are measuring the current passing through the aluminum wire, will you get the same value here, 0.5 amperes? Can anybody answer me? Are you expecting the same amount of current? No. My answer is no. Can anybody guess at least why not same? Why not same? Can anybody predict that answer? Simple, right? here, do you know atomic numbers of these elements? Suppose here I am asking you about aluminum and copper. What is atomic number of aluminum? Aluminum atomic number is 30, right? And copper atomic number is 29, right? So here proton count change and simply what is different? Electronic count, electron numbers, number of electrons present in them is different. So here if you take a fixed length wire and fixed area, L is fixed and area also fixed, then what about the number of electrons situated in the wire? Do the same? Not same. Not same. So which has fixed number of electrons large in the fixed area of wire, in which you have that more number of electrons in the copper, right? Free electrons increasing from aluminum to copper here. So automatically what happens? The amount of charge flowing through it, the amount of charge flowing through it increases. The amount of charge flowing through it increases because we decided already the current is due to motion of electrons. The current is due to what? Motion of electrons. They are free charges here, right? So here the density of electrons is changing, automatically the nature of the material changing, right? What nature? Allowing electricity or the conducting of electricity through that increases or decreases, whatever it may be, it happens, right? So simply nature is affecting, the material nature is affecting the amount of current passing through it. Amount of current passing through it calculated by what? The net charge crossing the cross-sectional area, right? So what amount of charges crossing the cross-sectional area here, crossing the cross-sectional area here from left hand to right hand and right hand to left hand vary. So that depends on what? Nature of the material. What nature? Simply allowing to pass. When it allows, if that made less number of collisions. If that made less number of collisions. So the number of collisions made by the particles in the material will decide the amount of current passing through it. If the collisions are increasing, what happens? Amount of current passing through it decreasing. So that obstructing motion of charges due to collisions, right? Obstructing the motion of charges due to the collisions. So number of collisions are increasing, automatically what happens? That will be change its direction, random with ordered motion. Finally it comes into a particular direction, whatever it may be, number of times it is changing its direction backward, halts, right? Finally it will be accelerated again, right? So that is not important here. It is simply importance given to the collisions made by it, right? So collisions increases, automatically electron motion will be controlled. If the motion of electron will be controlled, automatically what happens? Charge crossing the cross-sectional area decreases, right? So that decreases in the amount of current passing through it, obstructing at somewhere, right? So that obstructing nature, right? Obstructing nature is called as what? Resistance. Is called as resistance. So simply it is offered, right? Resisting the motion of electrons. That material nature only here defined as resistance. Look at that. The definition is given here. underline in your textbooks. So I am highlighting that in your on the screen. So the resistance of a conductor is defined as the obstruction to the motion of the electrons in a conductor, the material which offers a resistance here, right? More obstruction to the flow of charges, the material which can obstruct more amount of charges, right? That we can call it as here a resistor. So resistance and resistor, both you got. What is resistance here? Resistance is simply nature of the material. Resistor is simply it is a material. One is material and the other is nature of the material. Resistance, you cannot see this. Resistor, you can see this physically. Have you got the difference? Which we cannot see, which we can see. Are you able to see the resistance or are you able to see the resistor? Right? So resistor is the nature of the material. You cannot see that. You are able to measure it. Right? Resistance you are able to see physically. That is material here. Simply it is what? Material here. Okay. So understand about what is resistance, what is resistor. What is resistance? What is resistor? So resistor is a material that which can offer resistance, which can offer the resistance. So here simply in your bulb, what we have? Filament. Right? Filament is what? Simply it is resistor. Filament is what? Resistor. So that filament made up of tungsten. Right? Tungsten. Right? We can use the symbol volt from W. Okay. So simply resistor is physically visible, resistance just measurable. It is nature of the material. That nature is obstructing nature, obstructing the flow of charges or obstruction to the motion of electrons. That we can call it as resistance. So are you clear about resistance and resistor? Just go to quick reaction if it is clear. How to understand the resistance here, right? So clear, right? So now we will move to the another topic. What about it is electric shock, right? Electric shock. What is actually shock? Shock is what simply it is suddenly happens. Just your body felt something vibration. Your body felt something vibration. So it is due to what? Due to motion of or flow of charge through your body. Flow of charge through your body. That is called as here simply electric shock. If the certain amount of charge allowed through your body felt something a sudden vibration, sudden shake, right? Due to motion of charges through your body. That we can call it as here electric shock, right? So here our body also has something resistance, right? Human body also has resistance, not immunity power. That is different. Body resistance, right? So here towards electricity, that resistance we are calling as here simply human body resistance. That means what? Simply your body also obstructing the flow of charges, right? Obstructing the flow of charges. So that obstruction only here called as resistance. That body, human body also offering something resistance, obstructing the flow of charges through the body. So that we can call it as here human body resistance, right? So maximum is 5 lakh ohms, right? Maximum is 5 lakh ohms. the minimum resistance of human body is just 100 ohms, right? So when your body has maximum resistance, right? When your body has maximum resistance, it is completely dry skin, right? Fully dried skin. Minimum resistance offered by your body is at completely you are drenched with a salt, sweaty, right? So your body completely drenched with salt. Then it is called as here simply your body offering the lower resistance. That is 100 ohms, right? So it is given. Just make it underline. If your body or the skin is completely dry, then it offers 5 lakh ohms resistance maximum. If your body completely with salt water, right, then it offers very less resistance, that is 100 ohms. So maximum resistance of human body is 5 lakh ohms. Minimum resistance of your body is 100 ohms, right? So maximum 5 lakhs, minimum 100 ohms. Then what happens? Just you are in connection with a potential difference called 24 volts with a battery. What amount of current will pass through your body if your body offering something 5 lakh ohms, suppose. Your body resistance is taken 5 lakh ohms and the potential difference created through your body is 24 volts. What amount of current is passing through your body? So we will use the Ohm's law relation, that is V is equals to IR. Then to find out the current, just transpose the formula. Here I is equals to V by R. So what is V is here 24. And what about resistance here 5 lakh ohms. So what amount of current will be allowed? So just I am cancelling using the 5 table. So 5 ones and 5 4s are 20 and 5 8s are 40. So 4.8 by 1 lakh. So you will get here how many 5 decimals? So 0.0000048 amperes current will be allowed to your body. Suppose if that resistance further decreased to 1 lakh ohms, what happens? The amount of current will be allowed through your body, will become 0.000024, right? Zero, sorry. Is it correct one? Yes, correct, right? So here, okay. So here, depending on the resistance, sorry, I'm getting wrong. Can you find the mistake here? Actually, resistance decreasing, current value must be increased, but I am getting reversed. Can you find the mistake I made here? The revision I made mistake. Okay, once again I will solve. V is equals to IR, then R is equals to V by, sorry, I equal to I want, not R equal to. Then I is equals to V by R. So what is the value is taken for V here? 24 volts. Then suppose the resistance is 100,000, 1 lakh. Then what will be the value? You are getting here 1, 2, 3, 4, 5. Okay, sorry, here already it is 2 places, right? So it is moving, then becoming 0, 2, 4, right? I got what is my mistake. Okay, then for 5 lakh ohms, V equal to 24, same, no change. Then I is equals to V by R. V is 24 by R is 5 lakh ohms. So first of all, cancellation. What I will get? 4.8. So here, how many zeros are there? 5 zeros. So moving the decimal, 1 point to first place, second place, third place, fourth place. So it is enough. 0, 0, 0, 4, 8. So I got the mistake, right? So I solved it. So here what happened? The resistance decreasing, amount of current passing through your body increases. Have you got the difference? Raise your hand if there is any confusion in this, or use your quick reaction if it is clear calculation. How I got? Just assuming, right? Potential difference through your body and what happens with the resistance, the amount of current allowed through your body. Potential difference not varied. Potential difference created through your body is same, 24 volts only. But the resistance of the body assumed in different amounts. Once 1 lakh and the next is 5 lakhs. So the amount of current I got through our body is, in first case, that is 0.0024 amperes, and in next case 0.00048. So which is less amount of current? This is. Which is maximum amount? This is. So what happened? Here the amount of current is increased through our body due to decrease in resistance. So current and the resistance are in which proportional? Directly or inversely proportional? Can anybody answer here? What is the proportionality expected between the current and resistance here? Inversely proportional or directly proportional? Sharon, Rohit, Vikrant, anyone? Answer me. In what way you are giving the relation between the current and the resistance? Directly proportional or inversely proportional? Just observe the values here. Resistance and the amount of current. Resistance, once I taken R equal to 1 lakh. Resistance, I taken R is equals to 5 lakh. So resistance increased, then what happened to the current? Is it decreased or increased? Just answer me. With increase in resistance, current value decreased or increased? Am I audible? Just anyone answer? Proportionality relation here. Are you there in the meeting? Richard?
Sir,
Give me the relation between resistance and current here. Are they in direct proportion or inversely proportion? You have current values also on the screen. Look at that. Highlighted. This tick mark current values respectively. Which relation you can use? Directly proportion or inversely proportion? Inversely proportion. If the resistance increasing, current decreasing, so we can write the relation like this. Voltage is constant. Voltage is constant. So always the product of I and R value will give you constant. What the constant is here? Voltage equal to IR, same Ohm's law. Are you in confusion? This constant is what? You are only maintaining that, nothing, right? It won't come from somewhere. It is already you are maintaining in your activity. So by maintaining constant, you are finding the relation, right? So this is about completely resistance through your body. So what happens to your body resistance when the amount of current increases or simply current is allowed through your body? So when the current is passing through your body, there is a change in the resistance, right? When the amount of current is increasing through your body, resistance decreases through your body. Actually, the current chooses least, right? Current chooses least resistance path, least resistance path. Always it chooses the path in which path it has lowest resistance, right? So least resistance path is taken or chosen by the current once it's set to pass through your body, right? So simply, if the charge is allowed through your body, that is only here called as electric shock. So here simply, what amount of current will be give you shock here? So the amount of current 0.0024, 0.0024, that amount of current is allowed through your body. So when this quantity of current flows through the body, the functioning of organs inside the body gets disturbed. That disturbance inside the body felt as electric shock here. Electric shock is nothing disturbing the function of the organs in your body, right? So it gives you sudden vibration, sudden shake, right? So that is called as electric shock here due to motion of charge through your body. So if this current, what amount? 0.0024 amperes current, 0.0024 amperes current continuously passing through your body. What happens? What happens? It damages the tissues, biological terms, right? Cells or tissues, right? Whatever it may be. That inner organs will be decrease their strength. They are unable to perform their function, right? So that is the reason here. Simply that flows current continuously through your body, the damage in your body increases, and also with increase in the time of current passing through your body, that temperature of the body decreases, your body losing the heat energy, right? So once your body heat energy decreases, the function of the tissues will be further decreases, right? That simply causes death, right? So automatically the temperature decrease in your body. Again, the amount of current increases through your body without change in the voltage. The voltage is same, but the amount of current increases through your body, falling of temperature, right? So simply the amount of current increases through your body and reaching suppose 0.07 amperes current, right? Directly it can affect your heart function, right? So that can be called as fatal dose, right? Fatal dose. Fatal meaning is what here? It is simply which cause death, that which cause death. So that amount of current is called here fatal dose, right? That amount of current is called as here fatal dose. So if that amount of current just allowed through your body more than 1 second, the amount of current 0.07 amperes of current just allowed through your body, especially organ heart, right? Within 1 second, it stops functioning, right? So the person will be remains unconscious, death, right? So this is the effect of current through your body. So that effects are given in the table. If it is 0.001 ampere current, just your body felt that charge passing through your body felt that. If that amount of current 5 times 0.005 amperes, it causes pain. You will feel the pain of the shock, right? Then it is further increased 0.010, then it can give you that involuntary contraction. Muscles will become contract, right? So you are unable to expand. Just open your hand by holding your hand tightly here, right? So automatically your fingers closes itself without your involvement, right? So that type of muscle contraction starts in your body if 0.010 amperes current passing through your body. If it is further increased 0.015, then you will lose the control on the muscles. Then finally, if it is reaching 0.07 amperes current, then directly it can give you effect on your heart. If it is allowed more than 1 second, the person will be died, right? So this probably fatal if current lasts for more than 1 second. The person will be died, right? So we need to answer one question here. That is, electric shock is the effect of potential difference or the effect of